Hi everyone, my name's Paul Shiner. I'm a IoT Specialist Senior Solutions Architect at AWS based in the UK. In this video tutorial, I'm going to run through how to connect camera with an RTSP feed to a local Raspberry Pi device and then push that feed up to Kinesis video streams for consumption. We'll start with this simple diagram showing what we're going to build. So first of all, we have a CCTV camera or some camera existing on the local network, and there's millions of these in the market. You can just go on to somewhere like Amazon and you'll see here that RTSP as a connectivity protocol is featured as one of the checkboxes. So you can find a camera that will support this protocol in order for you to connect to your device. The next part we have is the Raspberry Pi device, which we're going to use as a local gateway to connect to the local cameras and then manage the connection and the stream up to Amazon Kinesis video streams. Now this is a simple diagram, but it shows the basic flow from the camera to the Raspberry Pi up to Kinesis video streams. But there are some other steps involved. Once we've installed the Producer SDK on the Raspberry Pi, this will allow us to stream to Kinesis, but we need some credentials. So we can use normal IAM credentials to connect to Kinesis video streams, but this means we have to put hard-coded credentials on the device. So the way that I'm going to choose to do it is to use some IoT credentials, an IoT certificate, in order to authenticate with AWS IoT Core. An IoT Core will give us a role alias that allows us to communicate with Kinesis video streams. So now that you have a basic overview of what we're going to build, let's get started with the tutorial. First of all, I'm going to download the Raspberry Pi imaging software. So I'm using a Raspberry Pi 3B. Just download that executable and click install, click finish. I'll choose the operating system, which will be the default Debian Bullseye. Select the SD card on the right. This is going to take a little while, so I'll skip through this. Okay, that's finished and verified. So I can now remove the SD card. I finished installing the Raspberry Pi operating system. I've set up the time zone, the keyboard, username, password, and done all the updates. And the other part that I've set within the Raspberry Pi in the configuration is I've enabled SSH and VNC. And the reason I've enabled these is so that we can remotely connect to the Raspberry Pi so that I can share the screen and show you what I'm doing on that device. So the first thing we need to test is that the RTSP camera feeds that we have from the cameras that we've got connected to our network are working. And the way we can do this is by using VLC media player that's installed with the Raspberry Pi. So if you've used the image that I've used, then this should be installed on your device. So if we open VLC, we can go to open a network stream and we can input the network stream address that we have. So this is one camera that I've got behind me where it's very simple. It's just got the IP address of the camera. If I click play, that will connect to that camera, and that's just looking at the wall behind me, so not very interesting. I've also got another camera on my network that is this IP address, so 192.168.0.102, and here we can see the embedded username and password in the URL. So the username is user and the password is password1, and the rest of this URL is dictated by the camera manufacturer. So you have to check the camera manufacturer's documentation to find out the exact URL that you're required and if they support this username and password. So if I play this camera, this one should hopefully be a bit more interesting. So this is the side of my house. So now that we know that the camera feeds are working, we can move on to installing the software and getting this video feed pushed up to KVS. So next we're going to install GStreamer and our producer. So what I'm using this GitHub repository link that you can follow. So here I'm going to clone and build this on the device. This includes all the packages that we need to include in libraries on the device in order to run this sample. First of all, I'm going to check that we have the libraries installed on the device that we're going to need to build the package. Next, I'm going to clone the repo. Then I'm going to create build directory, and I'm going to move into that build directory. Next, I'm going to install the libraries that are required. So as I mentioned, you can find these in here in the GitHub repository. So I can just copy that command, paste that. Then we should be ready to build. Show here. So when we build the Kinesis Video Streams Producer, we have the option to build the plugin, which should also build the samples that are in there as well. So we do want to build the samples because that's what I'm going to use to push this stream up to KVS. And this will take a while because we are doing this on the Raspberry Pi device itself. It can be faster if you run this on a faster machine, but for the purposes of this, I'm happy to wait. Okay, that's finished. I've had a cup of tea in that time. So now make the files. So this will take a similar amount of time, I imagine. That's finished. Let's just check the contents of the build folder to make sure that we've got everything that we need. So we should have in there this KVS GStreamer sample, and this is the KVS Sync plugin that we can use as well. If we want to use the KVS Sync plugin, we need to make sure that we set some environment variables. We're not using that, but we'll just set it now so that we can see it's installed and working. Just copy that and go up a level on that command. Then run the inspect on the KVS Sync component, and we can see that's installed, and that will show us some of the element properties as well with KVS Sync if we were going to use that. So there's two types of credential we can provide to make the connection to upload this stream. So the first of all is the normal IAM credentials, but the second part is the IoT credentials. So we can assume a role with a role alias using IoT credentials, and that's what I want to use on this device. The reason I prefer IoT credentials is not just because I'm an IoT specialist, it's that we can manage them in a more granular way. We can rotate those certificates and we can easily issue an individual certificate for each device. So I'm going to jump into the console, create an IoT certificate and thing to associate with this camera. The first camera I'm going to connect to is going to be the IP address that ends in 102. So I'm going to create a thing for that and run through the associated procedure needed to allow that credential to gain access to Kinesis video streams. So let's switch to the console. So here I've logged in and I'm going to go to IoT Core. So we're going to navigate to manage and then things. And first of all, we're going to go to types and we're going to create a thing type before we create a thing. So let's create a thing type. We can call this, say, CCTV underscore camera. We'll create that thing type. The next step we're going to go to is create a thing of that thing type. So let's create this thing, single thing, and we will call this, actually we'll call this camera underscore 102 because this is the IP address that ends with 102, and we'll make that thing type CCTV camera. So we'll go next and auto generate a certificate. We're not going to attach a policy at this time because we need to do some other steps first. So let's just create a thing and then we can download the certificates. So we need to download the device certificate, public key, private key, and a root CA. And that's to keep that. Then that's done. So make sure that you keep those certificates safe. So next we need to switch to IAM to create a role that will allow the device to connect and stream to KVS. So if we switch to IAM, and we go to roles, so we'll click create role, and then we can choose custom trust policy and paste this policy in. So the service will be IoT that will be able to assume this role. Next, we need to add the permissions for this IAM user, and we can create our own permissions policy for this. And I will paste in this policy. So this will allow us to describe the stream, put media, tag the stream, get data endpoint. And you'll notice that the Kinesis video stream has this condition that it will only accept the IoT credentials thing name. So each device will only be able to write to its own Kinesis video stream. So we need to remember that when we create the video streams within Kinesis, that we make sure that the name is the same as the IoT thing name. And we need to give this policy a name. Oh, back on the other tab, sorry. Just need to refresh that because we've created that in another tab. So this is the same policy we just created. Now we need to finish the role name. So this can be camera. Okay, and then we can create that role. Okay, that's creating the role. So that part's done now. So we've created a role and a policy within IAM. So let's just have a look, see if we can find it. So we can see this camera cert-based IAM role. This role will allow access to Kinesis video streams, and the trust relationship is it can be assumed by the IoT service. So now let's switch back to IoT. Make sure when you switch back from IAM to IoT core that your region doesn't change, as mine just has. So I'm going to have to make sure I go back to Europe Ireland, which is where I want to host my devices and where I hope I created devices earlier. Let's just check. That's the case. Yep, there's my camera up 102. So the next part we want to create is the role alias. So let's go to role alias and create role alias. So let's name this role alias, CameraIoTRoleAlias, and select the IAM role that we just created. Camera cert based IAM role, and then click create. So it's good, the role alias is created. Next we need to create a policy to attach to the certificates for that device. So if we go on the left and policies, and we create a policy, we'll call this camera policy, and we need to add some actions here. So IoT connect, and the policy resource that we want to connect to is the role alias within IoT core. So if I just switch to another tab and make this one go to IoT core, we can get the ARN of the role alias that we want to connect to. So again, just make sure that you're definitely in the region that you want to place the devices. So if we find our role alias, which is this camera IoT role alias, and copy this on into here, then we also want to assume role with certificate. That's the role that we want to assume. And I'll just switch to JSON view just so you can compare that to what you have at your end. It's a bit easier to see. And then we'll create that policy. And the next step is to go to the thing that we created earlier and attach this policy to that thing certificate. We could go into the certificates here and attach it directly to the certificate if you knew the certificate number, but that's not so easy to remember. So it's easier to go into the thing under the certificates, into the certificate ID, and then we can attach that policy. We should have this camera IoT policy. And now that's attached, the camera thing should be able to use the role alias to assume that IAM role in order to stream to the Kinesis video streams channel. So lastly, before we switch back to the device to carry on configuring the device, we just need to make sure that we have a Kinesis video stream available for us to write to, and that stream will have to have the same name as this, the thing that is going to connect to that. So we can just copy that name and then switch to Kinesis video streams, or KVS for short. And we can go into the video streams section on the left, create a video stream, and here we can set the retention time for this. So if I select this info, you can we can customize this data retention. As I'm using this for camera monitoring, I actually want to extend this data retention. 1 day is not enough because I'm going to want to play back, and you can see the maximum duration we've got is 10 years. So I'm going to set this to 1 year retention and then create that video stream. So now it's time to reconnect to the device. VNC is timed out. First of all, we need to copy the certificates to the device. So we can use VNC for this to transfer those files. Okay, so those files, as you can see, have appeared on the desktop on my device. I'm going to just copy those into a certs folder within the build. And I'm going to rename these files just to make the file names a bit smaller for when we're passing these values. As you can see, they're very long. So the sample file we're going to run will use these certificates to connect to IoT Core and then in turn publish the video to Kinesis video stream. So if we go up a level, we should see this KVS GStreamer sample in the build folder. So if we switch back to the terminal window, just change directory to the build folder, and the command we're going to run will look something like this. So running that KVS sample, the next part is the camera feed, so camera 102. That's the stream that we created, that is the target. And then the following is the camera RTSP stream. So if we try and run that command now, that won't work. And we can see why. The reason is that there are some environment variables that we have to set in order for that sample file to be able to connect. And we can look at those in the source code. So in the source code, we can see the samples folder. In there, in the GStreamer sample source code, if we scroll down to line, let's have a look, there it is, 517, we can see that we need to provide the IoT credential endpoint for this to validate its certificates, the cert path, the private key path, the role alias of the role that we're going to assume, and the CA cert path. So let's go back to the device and add those environment variables now. So the first one I'm going to add is the easiest one, which is the region, the default region we want this to use. That's clear. So here we have the region, which is EU West 1, for the region that I'm using on my device and my stream. So if you want to check your region, you can just go back into IoT Core or wherever you're looking, and then up at the top here you'll see EU West 1 because I'm using Ireland. So that's the region done. The next part is the cert path. So the cert path will be as we've defined here, so in reference to the cert folder that we created. So as we're running from the build folder, this will be certs / and then the name of the cert file, the cert file. Then the next file will be the private key, and the next one will be the root CA file. And then we need to provide the role alias that we're going to assume. So if you can't remember the role alias, you can switch back into here, go back to IoT Core, and under secure you will find the role alias, and then it's, for me, it's CameraIoTRoleAlias. If you want to be sure, you can just go into the actual role alias as well. And then the final environment variable we need to add is the credential endpoint. Now we need to get the credential endpoint for our particular account. And one of the easiest ways to do this I've found is to use Cloud Shell. So I'll duplicate this tab just so I can come back to that one. So you should be able to find Cloud Shell in your console. This can sometimes take a few seconds to start. And if we paste this command, which is IoT describe-endpoint, endpoint-type is a credential provider. This will be your credential provider unique endpoint for that account in that region. So if we copy this and then switch back to the device, then that should be it. We should be ready to run this command again, and hopefully that will connect. So as I mentioned earlier, this is the KVS GStreamer sample that we're running. The stream will be camera_102. Remember that your stream has to be the same as the thing name because of the policy we attached to the certificate which had that condition. And then the real-time streaming protocol URL that's there that will be specific to your camera. Hopefully you should see something similar to what I'm seeing. So if we switch back and go to the Kinesis under the video streams on the left here, we should see our camera 102. And then if we open media playback, that's great. So we can see that stream coming in now. I can see that I know that stream is running and there's the time at the top there because I've got a timestamp on the stream. You can also look in the monitoring tab at the bottom, and this should show you some metrics for how often the put media has occurred. So at least you can fault find if that's not coming in at any point. You can see that maybe sometimes what you see is the browser or the machine that you're viewing this on won't have the codec or they necessarily have all the requirements to play the media in the browser. So if you don't get the media in the browser, just check and make sure that you can see some put media actions happening in the monitoring. And if you can, then suspect the browser and try and figure out why that's not displaying. So that's great. We've now got the feed coming into KVS using the IoT certificates. And as I set this to a retention of 1 year, I'll be able to go in here and actually go back in time and view what's happened in this camera feed. You can see some media statistics here. So I've set the resolution of my camera particularly low. I've just done that to save bandwidth and it was easier at the time, but you can run higher resolutions than this if you wanted to. If you've had any problems or issues setting that up, or you've got any further technical questions, one great place to go is www.repost.aws. This is a community forum run by AWS, and here you can find answers to commonly asked questions, or you can even post your own questions. And it's moderated and viewed by AWS employees as well. So you can even search for me on here and follow me as a user, or even ask a question directly. So now that we have the stream being uploaded to Kinesis video streams, in the next video I'm going to show you how to extract images from that stream. And once we have those images, we can pass them into Amazon Recognition and use the labeling feature for Amazon Recognition to identify what's in that image, such as cats, chairs, everything else that we might want to look out for. Once it's processed those images, we can attach the metadata to that and place them in another S3 bucket where another Lambda function can consume them and decide if there are any notifications that need to be sent. So what we'll be doing is setting up a simple notification that will tell us when something has entered the image, such as a cat or a dog or a fox. And that'll be in the next video. So please join me then.